This is the third video on icse class 10 quadratic equations exercise 5.5 of ML Agarwal. Now, in the previous two videos, we have already discussed questions based on numbers and fractions and area and perimeter. If you have not gone through the videos, I'll send a link at the end of the video to the playlist and to the previous videos. So this video is actually based on the questions problems on speed, time and distance. In this question, the given things are speed of the express train, that's x kilometer per hour, speed of the ordinary train that travels at a slower speed of x minus 12 kilometer per hour, 12 kilometer per hour lesser than that of the express train, and this is the speed of the express train. And the total distance between two stations is 240 kilometers. Okay, so the total distance covered by the two trains is 240 kilometers. There is one more condition, that the ordinary train takes 1 hour longer, so the time taken by the ordinary train is 1 hour more than that of express train. Now let us try to understand this situation with the help of a small animation. As you can see, we have two stations, station A and station B, and the distance between the two stations is 240 kilometers. Now let us bring our express train and the ordinary train. Let us say the express train travels with a speed x kilometers per hour. Okay, now the train has reached its destination at P, covering 240 kilometers with x kilometers per hour speed. So the total time taken by the express train is total distance covered by the speed. Okay, so that's 240 by x. This is the time taken by the express train. Now let us bring our ordinary train to the track. The ordinary train also the same distance, 240 kilometers, but with a slower speed, 12 kilometers per hour, slower than the express train. So the ordinary train takes much longer than the express train to cover the same distance, and the time taken is 1 hour more than the time taken by the express train. So what is the time taken by the ordinary train? It's total distance divided by the speed. So 240 divided by x minus 12. Now if we write this in the expression, we have to look out for the comparison, right? We can compare the time expressions here. So the time taken by the express train is 1 hour less than the time taken by the ordinary train. That means if we subtract the time taken by express train from the time taken by ordinary train, we get 1 hour, or we can say the ordinary train time is 1 hour added to the time taken by the express train. Thus we can write the expression time taken by ordinary train minus time taken by express train equals to 1 hour. That's 240 by x minus 12 minus 240 by x equals to 1 hour. Okay, you have to pay attention to the units here. This speed is kilometer per hour, this is kilometer per hour, and so the time is taken in hours. So solving this, you will get a quadratic equation taking the LCM, x into x minus 12. We get 240x minus 240x into minus 12. Sorry, x into x minus 12. We get 240x plus 12 into 240. Okay, so equals to 1. 12 into 240 equals to x into x minus 12. That gives us x square minus 12x, and bringing this to the right side, we get 12 into 240. This is equal to 0. So we have got our quadratic equation. That's x square minus 12x minus 12 into 240 equals to 0. This is how we solve the quadratic equation. You can pause the video and see if you are right. We get x equals to 60 and x equals to minus 48. So x equals to 60 or x equals to minus 48. Now you remember what x is the speed of the express train, right? So x cannot be negative. Speed cannot be negative. Hence, speed of the express train equals to 60 kilometers per hour. And this is your answer. If you want to verify whether your answer is correct or not, you're just going to check the timings of express train and the ordinary train. So speed is 60 km per hour for the express train, and time taken will be 240 by 60. This is express train timing, and that's 4 times, and so 4 hours. This is the time taken by the express train. Now time taken by the ordinary train, we get 240 divided by 60 minus 12, so that's 48. And that takes 4 goes, this is 240, right? 4 goes 60 times 4, 12, and 12, 5. So it takes 5 hours. That's 1 hour more than the time taken by the express train. Hence, we can see that the condition is fulfilled based on the answer we have got. That means our answer is correct. In this question, the total distance covered by a car is given 400 km, and the speed of the car, we assumed it had the speed been 12 km per hour more, that means the speed has gone up by 12 km per hour, then obviously the time taken will be less. So that's 1 hour 40 minutes less to cover the same distance. Now this question is similar to the last question. There is a small difference that we have 2 different trains here. We have the same car here with different speeds. Okay, so you have to find the original speed of the car. Suppose this car travels a distance of 400 km with speed x km per hour. Okay, now it has covered the distance, and the time taken by the car will be total distance covered by total time taken. Total distance covered by total speed. So that's 400 by x hours. Okay, now let us consider an example where the speed goes up by 12 km per hour. I understand that this car doesn't look like the previous one, but just to keep the context here, I just tried a different car here with a speed more than the previous one, and it travels with x plus 12 km per hour to cover the same distance. Then the time taken by the car will be 400 by x plus 12. Okay, now again we have the time comparison here. So the time taken when the speed is more is generally less than the original time because the speed was less here. So by how much? It's 1 hour and 40 minutes. So the time taken equals to 400 by x hour. and the new speed is x plus 12 km per hour. Then the new time taken will be 400 by x plus 12 hours. According to the problem, the new time is less than the original time, so by how much? 1 hour and 40 minutes. You can also write that original time minus new time equals to 1 hour 40 minutes. So here we are going to compare the timings of the two conditions. So we have 400 by x plus 12 equals to 400 by x minus 1 hour and 40 minutes can be converted to hours by 40 by 60. So this is now in hours. So we have 400 by x minus 400 by x plus 12 equals to, this goes to the left side, so we have 1 hour and 40 by 60, 2 by 3. You've got the expression, you just need to convert it to quadratic equation. So taking LCM, x into x plus 12, similar to the previous one, equals to this is 5 by 3. So you can cancel 5, 8, 10, so you get x squared plus 12x, so 3 into 12, 36 into 80, minus 36 into 80 equals to 0. Now on solving this, you need to solve it, right? So here is the solution. This is just like the previous one. Only thing here is you have a plus sign in place of minus sign in the previous one. So this is how you split the middle term, and you get x equals to minus 60 and x equals to 48. So we have x equals to minus 60 or x equals to 48. So we cannot take speed to be negative. So speed of the car equals to 48 km per hour, and that is the required answer. That's the original speed we are talking about, because the new speed is 12 km per hour more than this. And this is a different type of question where you have an aeroplane flying. The speed of the aeroplane is not given. Rather, the speed of the wind is given. Speed of wind is 30 km per hour, and it takes 40 minutes less when it flies along with the wind and covers 3600 km. So if it is going against the wind, it takes that 40 minutes more than the previous one. Okay, so what it would take to fly against the same wind? Find the plane speed of flying in still air. Okay, so you need to find the actual speed of the aeroplane. So we'll write what is given. Let the speed of the aeroplane in still air be x km per hour, and the speed of the wind is given 30 km per hour, and the total distance covered is given 3600 km. Let us say the air or the wind flows from the left to the right direction with a speed of 30 km per hour. Now, what happens when an aeroplane flies along with the wind? So the total effective speed of the aeroplane is increased by 30 km per hour, because this is the speed of the plane and this is the speed of the wind. So it is flying along with the wind. So the speed increases, effective speed increases, and it is x plus 30 km per hour. So let us assume that the plane is flying along with the wind. Okay, so it takes time less when it travels along with the wind, and it takes more time as it goes against the wind. The wind is flowing from the right to left, so it takes more time to cover the same distance to reach its destination. And time taken in this case will be more. The effective speed in this case is less than the previous one, and it is x minus 30 km per hour, because it is going against the wind. So the wind is trying to stop the plane and push it backward with the speed of 30 km per hour. So the speed, effective speed against the air is x minus 30 km per hour. Now in the previous case, the time taken will be 3600 divided by x plus 30, and here the time taken will be 3600 divided by x minus 30. Okay, I hope you understood the concept here. So we have two conditions. When the plane is flying with the wind, effective speed is x plus 30 km per hour, and the time is 3600 upon x plus 30, and here the time is 3600 upon the effective speed is x minus 30, and both are in hours. Okay, now according to the given condition or the problem we have, the time taken by this latter part is more, and this one takes 40 minutes less. So that means time, this 3600 by x minus 30 is greater than 3600 by x plus 30. By how much? It takes 40 minutes more. Since the speed is given in kilometer per hour, these times are in hours, and the right hand side you need to convert it into hours. So it becomes 40 by 60, and you get hours. So now you can write the quadratic equation. That's x minus 30 into x plus 30 equals to, this is 2 by 3, and in the numerator you have 3600x. Here also you'll have 3600x, which is both of opposite signs, so it gets cancelled. You have 30 into 3600, and then minus into minus plus, so again you have 30 into 3600. So this is 2 times. We have 3 into 30, 90 into 3600. 900 comes to the left side, you get plus 900 equals to x square. So we have x square equals to, from this part we can take 900 and 900. So if I take 900 common, I get 10 to 900 here, so 360, plus here we have 1, so that's 900 into 361, and we can express it as 30 square into 19 square. Okay, so x equals to, this is x square, x equals to plus minus root over 30 square into 19 square. You get plus minus 30 into 19, that's plus minus, if you multiply this you get 570. So x equals to 570 or x equals to minus 570. So speed cannot be negative, so discarding the negative value, we have speed of aeroplane in still air equals to 570 km per hour. Now this question is more or less of similar type to the previous one. In place of aeroplane we have a boat here, and it covers 10 km up the stream. It's similar to going against the air or wind. So 10 km up the stream, that means the boat is going against the flow of water. So 10 km up the stream and 5 km down the stream, so it is going along with the water. It's similar to going along with the wind direction. Okay, it takes, total time is given 6 hours. If the speed of the stream, so like the speed of the wind, speed of the stream is given 1.5 km per hour, you have to find the speed of the boat in still water. So let us assume that the speed of the boat be x km per hour and the speed of the stream is given 1.5 km per hour. You can keep it like that, or you can convert it to fraction 3/2 km per hour. Now there are two situations, upstream and downstream. Suppose the water flows from the right side to the left side with a speed of 1.5 km per hour and its direction is from right to left. Okay, and the boat goes 10 km upstream, so going against the water. So the boat is going against the water with the speed of x km per hour, but the effective speed of boat upstream will be x minus 1.5 km per hour. Okay, so the time taken will be the total distance is 10 km upstream, so 10 by x minus 5.5 1.5, so that is in hours. Okay, the boat goes downstream, so it's moving along with the direction of flow of water, so it goes 5 km. Okay, in that case the effective speed will be x plus 1.5 km per hour, and the time taken will be, since the distance is 5, it should be 5. Okay, so 5 by x plus 1.5. Okay, so this is the time taken by the boat to travel 5 km downstream. So upstream the effective speed is, distance is speed is x minus 1.5. It's the speed of the boat minus speed of the stream, kilometer per hour, and speed downstream, that's effective speed in this case is x plus 1.5 km per hour. Okay, so the time taken in this case, time upstream equals to, distance is 10, so divided by x minus 1.5, or that's 10 by x minus 2/3 hours, and here the time downstream is, distance covered is 5, so we have x plus 1.5 or 5 by x plus 2/3. Okay, So the total time taken is 6 hours. So that means if we add those two times, that's 10 by x minus 2 by 3 plus 5 by x plus 2 by 3 is equal to 6. So this is our expression. We need to convert this into a quadratic equation. This is how we solve it, and we get the quadratic equation 2x squared minus 5x minus 7. Okay, so on solving the quadratic equation, we get x equals to minus 1 or x equals to 3.5. You can pause the video and go through the solution part. So on solving this, we get x equals to minus 1 or x equals to 7 by 2, that's 3.5. Now what is x? X is the speed of the boat. Cannot be negative. So speed of the boat equals to 3.5 in still water. Okay, 3.5 kilometer per hour. In this question we have two pipes that are running together to fill a tank in 1 by 9 minutes. Okay, so the total time taken by the two pipes is given 1 by 9 minutes, and the one pipe takes 5 minutes more than the other pipe. That means the water flowing out of this pipe is less than that of the other one, because it takes more time to fill the tank. Find the time taken in which each pipe would fill the tank separately. Okay, so you have to find out the time taken by both the pipes separately to fill the tank. To understand this concept, let us have an empty glass to be filled by water. If the water takes 5 seconds to fill the glass to its brim, how much part of the glass will be filled in 1 second? You can see that the water fills 1/5 of the part of the glass in 1 second. So if it takes 5 seconds to fill the whole glass, then the part of the glass that is filled in 1 second will be 1/5, in 2 seconds it's 2/5, in 3 seconds it's 3/5, and like that. So in 1 second the part of the glass that is filled is 1/5 of the glass. Similarly, when pipe 1 fills the tank in x minutes, so the part of the tank filled by pipe 1 in 1 minute will be 1 by x of the tank, and the other pipe that is running slower will fill the tank in x plus 5 minutes. Then the part filled by that slower pipe in 1 minute will be 1 by x plus 5. Now what happens when we take both the pipes together? Then it fills this and this together in 1 minute. So part filled by the first pipe and the part filled by the second pipe. So the part filled in 1 minute taking both the pipes together will be the sum of those two, which we can see that both the pipes are running here. So pipe filling the tank in x minutes, and this one fills the tank in x plus 5 minutes. So now it is also given that together the time taken is 100 by 9 minutes or 1 by 9 minutes. Okay, so part filled in 1 minute, If the time taken by both the pipe is this, then part of the tank filled by both the pipes together in 1 minute is reciprocal of that 1 by this time. So we have 1 by 100 by 9 of the part of the tank. That's 9 by 100 of the tank. Now you can see that these two expressions are actually the same. So we can equate them to find our given expression. So this is the time taken by first pipe, x minutes. The time taken by the second pipe is x plus 5 minutes. Now, part of glass or the tank here, part of tank filled by first pipe in 1 minute equals to 1 by x. Similarly, part of tank filled by second pipe in 1 minute, that's 1 by x plus 5. Thus, part of tank filled when both pipes are running in 1 minute equals to, we have to add those two, that's 1 by x plus 1 by x plus 5. Now also time taken to fill the tank by both pipes together is given 11 1 by 9 minutes, and that's 100 by 9 minutes. So part of tank filled with both pipes running in 1 minute equals to 1 upon 100 by 9, that's 9 by 100th part of the tank. Now as we can see from the previous expression, so according to the problem we have, those two conditions are equal. So 1 by x plus 1 by x plus 5 equals to 9 by 100. So I got our expression for the given question. Now just convert it into a quadratic equation and solve it for x. So writing everything on the right side, we get 9x squared plus 45x minus 200x, that's minus 155x, and minus 500 equals to 0. So we can write it like 9x squared minus 155x minus 500 equals to 0. Now solve this. So this is how we solve, and after solving we get x equals to 20 or x equals to minus 25 by 9. So we get x equals to 20 or x equals to minus 25 by 9. So x is the time taken by the first pipe to fill the tank, so it cannot be negative, and since we have covered everything in minutes here, so the time taken by first pipe equals to x minutes, that's 20 minutes to fill the tank, and time taken by second pipe equals to x plus 5 minutes. That's 25 minutes. So here is the verification part in case you want to go through. So if the pipe 1 takes in 1 minute, it covers 1 by 20th of the tank, and the pipe 2 covers 1 by 25th of the tank. Now together they will cover 1 by 20 plus 1 by 25. On solving this, you get 45 by 500, which is equal to, that means time taken by both the pipe filling the tank together will be 100 by 9, which is given in the question. Now that means our solution is right. That's all for now in this section. I hope you liked the bit of animations I tried. Thank you. See you in the next class.